Welcome back, everybody. In this video, we'll be discussing the muscle contraction related to the physiology part of it. So in this presentation right here, we're seeing probably the end stage of how things happen after the ripple effect of an action potential on a muscle that spreads, and then we reach to the stage where there's a power stroke process that guides the muscle to shorten. Okay, so keep in mind that I will return to this one as I show you the steps that happen as beginning with the action potential towards reaching the shortening of the sarcomere that involves two of those components which are part of the myosin-actin interaction. Okay, so troponin and tropomyosin, when we bring up those two, we're basically talking specifically about the actin filaments because these are the main regulators of how the power stroke is allowed to happen. So troponin, these are the molecules here that is basically the main regulatory molecule, and tropomyosin is the one that can be activated or deactivated due to the action of troponin. So how does this happen? Calcium is the main molecule needed, okay? So if calcium is present around those two components of actin, what happens is calcium binds to the troponin C part of troponin molecule. And so what it does is probably changes its conformation. And when troponin changes its conformation, it will move tropomyosin a bit. And so when this molecule moves, that this rod-shaped look here, when it moves from its place, it reveals on those actin subunits here, those balls right here, it reveals just maybe just imagine there's a site here on every ball just below this blue rod. It reveals a site where myosin head can bind. So let's repeat that again. Calcium binds to troponin. Troponin changes its shape. So when it changes its shape, it moves away tropomyosin from the active sites of actin. Now actin active sites are revealed, and so myosin heads can bind to actin. And so when myosin binds to actin, that's when it's able to cause this flicking power stroke movements that is the main purpose or the main driver of this contraction process that happens in the muscle due to the effect of an action potential. Okay, so now we're going to talk about details of how this power stroke happens after myosin binds to actin. Okay, very specifically we're starting here, but I will show you the general image of how everything happens from A to Z in a bit. So now we're going to start here. Let's say that myosin is bound to an actin molecule. Okay, myosin bound to an actin molecule. So when myosin binds to actin, we know that ATP is hydrolyzed already to ADP and PI. So let's imagine the process starts, myosin bound to actin with ADP and PI binding to the myosin head as shown here. Okay, so now to cause the power stroke, what happens is the PI or phosphorus is released. And so as soon as phosphorus is released, the energy from this phosphorus molecule is given to the myosin head to cause this power stroke. So now it moves from just being straight here towards the left, and so it becomes bent, right? So now after it moved, what's bound to it left is the ADP molecule. And so what happens when the ADP molecule is released? What happens is ADP released, and so myosin head now is waiting for something to detach it from actin. Okay, so first PI removed, so power stroke happens. Next, ADP is released. Still, myosin and actin are still bound at this point. So to remove myosin from actin and go back to redoing this process again, this has to detach. So what attaches to the myosin head is a new ATP molecule. When ATP binds to myosin head, it detaches away from actin. Okay. Now, the next thing what happens is ATP becomes hydrolyzed. So when ATP is hydrolyzed to ADP and PI, myosin again binds to actin. So now when it's bound again, we have ADP and PI attached to myosin, and the myosin head is attached to actin. And so the power stroke cycle goes on and on and on until the right contraction amount is produced. Okay, that's the contraction cycle. So what starts all of this? How do we reach to the point where actin and myosin interact? So the first thing we have to know is that at the neuromuscular junction is where there's a neuron that is attached to the fibers of the muscle, and this neuron, the main function of a neuron, is to deliver action potential to cause contraction to the muscle. So what happens is action potential come and arrive at this site called the neuromuscular junction, where there is neuron and muscle, where neurons interact with muscle to deliver that action potential into the muscle. And so what happens is action potential would arrive at the site of the axon terminal. Once that happens, this causes CA2 plus channels to open, allowing the influx of CA2 plus inside the axon terminal. This in turn causes vesicles, right here, vesicles containing acetylcholine hormone. It's a stimulator, okay, to be released in the synaptic cleft. And so what happens, those vesicles fuse with the presynaptic cleft, presynaptic membrane, releasing the ACH, acetylcholine molecules into the synaptic cleft. And so when it's released into the synaptic cleft, those molecules will go and bind to receptors that are found on the postsynaptic membrane. And so this causes channels to open. And so this voltage gated channel would be stimulated by ACH, causing an action potential to be induced in the muscular fibers. And so what happens is that Na plus would get, there's an Na plus influx into the muscle fibers, and K plus would move out. This causes an action potential in those muscle fibers. And so this action potential now would spread across the muscle to cause an effect of secretion of CA2 plus, which is we're going to look at in a bit, which then is the main source of starting the interaction of actin and myosin. So this is what happens. So as I said, through the process I said previously, now action potential is induced in this muscular fiber, and so action potential now travels. And so same thing happens for the channel, influx of Na plus, outflux of K plus, and then action potential would propel in front until it reaches towards something called the triad, a region called the triad. So the triad is basically made up of a T-tubule in the middle and a terminal cistern of the sacroplasmic reticulum. So the action potentials would reach the sacroplasmic reticulum, and so this action potential would cause an effect on the sacroplasmic reticulum, causing it to release the calcium ions. Okay, so let's look at it. What happens is, this is the action potential right here. It would arrive at a region, cause a change, and then so CA2 plus is released. So what is the specific process at the sacroplasmic reticulum? Here, so action potential would arrive right here. What causes release of CA2 plus is the presence of two molecules that are needed. First, the dihydropyrimidine L-type calcium channel, which is this one right here, and the ryanodine receptor channel. So when this calcium channel is stimulated, it would unplug the ryanodine receptor from the ryanodine molecule here from this molecule, or this channel, and so causing a space of flow for the calcium ions to be secreted into the sacral lemma. And so when secreted into sacral lemma, finally, we reach the main purpose here of the contraction of the muscle, the region where actin and myosin are present. So CA2 plus would interact with troponin C part of troponin molecule, changing its shape, causing it to cause the movement of tropomyosin, revealing the binding sites of actin, allowing for the binding of myosin heads to actin. And so what causes the contraction here is the power stroke that we spoke about, because mainly of the presence of the Ca2 plus ions. And so now ATP here is needed to cause the attachment of myosin to it. Then it gets hydrolyzed. Presence of the phosphorus causes the main motion. Then the ADP molecule is released, and so myosin is released from the actin molecule by the binding of an ATP, another ATP molecule, and so the process continues until the contraction goal is reached. So this is it. So as I said, Ca2 plus binds here, causing the process that I just mentioned a bit ago. So this is all connected in a way from the action potential down to the interaction of calcium ions with the actin and myosin filaments. And so remember that Ca2 plus is released in a cytoplasm kind of environment called the sacroplasm, which is related to the muscle environment where all of those things exist. Okay, and so this is how muscle contraction occurs. Thank you guys for joining on this video. I hope this explanation was as clear as possible. If you have any questions that I need to clarify, please put them down in the comments below. Like and please subscribe if you want to see more of those videos. Thank you very much for supporting me, and I hope this video was useful. Have a beautiful day.